Hello students. So in today's video we are going to solve one typical example on the work energy principle. So let us read the statement. A roller coaster rolls freely without friction along the looping rails as shown in figure. Find the necessary height h so that the coaster released from A should not lose contact with the rails at B while negotiating the vertical loop of radius 3 meters. So this roller coaster, it is moving along the vertical loop. So when it is released from A, when the speed of the coaster is 0 at A, what should be the necessary height so that it should not lose contact with the rails at B, means it has to negotiate that point, right? So first we will find out the speed of the roller coaster at B so that it should not lose contact with the rails. So what is the minimum speed of the coaster so that it should not lose contact with the rails at B? Now after finding the speed of the coaster at B, you know the speed of the coaster at A, that is 0. So using work energy principle from A to B, you can find out the required height, necessary height, right? So first to find out the minimum speed required at B so that it should not lose contact with the rails, let us draw free body diagram of the coaster at point B. So FBD of the coaster at B. So this coaster is negotiating a curve, right? So what are the forces acting on this? You have weight of the coaster vertically downwards, mg, the normal reaction offered by the rails on the coaster, which is also downwards, say nr, and it is moving in the vertical loop, so moving along the curved path. So it will have tangential component of acceleration at and normal component of acceleration an towards the center of curvature. Right. Now taking x-axis horizontally, y-axis vertical. So using Newton's second law of motion in y direction, that is summation Fy is equal to m into an. An is acting downwards, so it is minus m an. Newton's second law of motion states that unbalanced or resultant force is equal to mass into acceleration in the direction of the force. So it is minus mg minus nr is equal to minus m an. So it is m an is equal to mg plus normal reaction. So m into an is v square by rho, normal component of acceleration, is equal to mg plus nr. Now here m, rho and g are constants. So here v square, it depends on the normal reaction. For v to be minimum, normal reaction should be minimum. So what is the minimum possible value of normal reaction? That is 0. Means when normal reaction is 0, that means it is about to lose contact, tending to lose contact, right? So that the minimum velocity required. When it is about to lose contact but not losing contact, it tends to lose contact, right? So the normal reaction is 0. So you have V is equal to square root of rho into G. That is square root of rho is given 3 meters, radius of curvature into 9.81. So the minimum speed required is 5.42. So it is 5.42 meters per second. So when the coaster is maintaining 5.42 meters per second at B, then it can negotiate the curve, right? It will not lose contact, but about to lose contact, but it is not losing contact with it, right? So we have velocity or speed of the coaster at A as 0, speed of the coaster at B is 5.42 meters per second. Now what is the vertical displacement from A to B when the coaster is moving from A to B? So what is the vertical displacement? So it is total h minus 6 and it is downward displacement, right? So h minus 6 meters. Understood? Now using work energy principle from point A to B. So A is the initial position, B is the final position. So change in kinetic energy KEB minus KEA, final kinetic energy minus initial kinetic energy, is equal to work done between the positions A and B. Now what are the forces doing work on the coaster when it is moving from A to B? First you tell me what are the forces acting on the coaster. One is the gravitational force, the second is the normal reaction, and being it the loop is smooth, there is no friction, but work done by normal reaction is always 0. So only the gravitational force is doing work. So it is work done by gravity. Now what is kinetic energy at point B? Half into m into v square, that is 5.42 square, minus kinetic energy at A is 0, being velocity or speed at A is 0, is equal to work done by gravity. Work done by gravity is positive or negative? Here it is having downward displacement, so the work done by gravitational force is positive, plus m into G is 9.81 into what is the vertical displacement h from A to B, it is h minus 6. So into bracket h minus 6. So you can cancel m. So solving this equation, you have h is equal to 7.497 meters. So it is the height required, necessary at A, so that the coaster can negotiate the vertical loop at B. So first we are finding the minimum velocity or minimum speed required at B to negotiate the loop, and then using work energy principle we are finding the necessary height. Understood? Thank you.